Welcome to Chapter 17. Last chapter, we started by looking at how the Federal Reserve Bank could pump money into the banking system, and then it would come into the monetary supply. In this chapter, we're going to examine exactly what happens to the economy when the Fed does add money to the money supply, and particularly what happens if they add too much. Basically, we're going to use the quantity theory of money to explain this, and it helps answer the question, what happens when the Fed pumps too much money into the economy? And the answer is prices rise when the government prints too much money. We're going to discuss basically this proposition the whole rest of this chapter. This quantity theory is the way that most economists think that the long-run behavior of inflation works. So we're not going to touch actually the short-run behavior. That's for later chapters. We're going to think about what happens in the long run when the government prints too much money. All right, let's think real quick. I'm going to define P as the price level. Okay, think of it as the CPI, the price of one shopping cart in the CPI. And then I want to ask, how much is $1 worth? It's worth 1 over P. And that's measured in goods. Here's an example. Imagine the shopping cart for the CPI contains only one candy bar. Well, if price is equal to 2, then the value of $1 is a half of a candy bar, right? So the value of the money is 1/2. If price equals 3, then the value of $1 is 1/3 because it can only buy 1/3 of a candy bar. As you see, as the prices rise, as P gets up, then the value of money, 1 over P, goes down. The quantity theory of money is developed in the 1700s, and it's actually been used even recently, and it's thought of as the way to understand what happens when we add more quantity of money into the economy. So basically, the idea is that the amount of money, the quantity of money, is what determines the value of the money, right? So if you have a certain amount of quantity of money, it's going to change the value of each dollar in society. It's pretty self-explanatory. We're going to go ahead and show two ways. We're going to do it with a diagram, a supply and demand graph, and then I'm going to do it with an equation. All right, so think about the money supply. Who supplies the money? Well, it's what we studied last chapter, and basically the Fed pumps in money and then it comes out into the money supply. In this simple model, we're just going to assume that the Fed puts exactly X amount of dollars into the government, or into the economy, excuse me. Who demands money? Well, it's the people who want to hold onto currency. Remember, liquid, things that can be like cash that can be easily transferred into a purchase. Right? And so if the price level P is higher, then I need more money to purchase my goods, therefore I want to hold more currency. Okay, so quantity of money, the quantity of money is negatively related to the value of money, and it's positively related to P. So as price goes up, the quantity of money demanded also goes up. Let's show you kind of what this looks like. All right. You see here, this is a traditional supply and demand graph. This is the axis that normally has the price of the good, and this has the quantity of the good. The only goofy thing with this is the quantity of the good's money, and this is the value of that money. This is really kind of the price of the money, or the value of the money. It just so happens that we already defined that as 1 over P. So don't get confused that on the y-axis, which is normally just plain old P, is 1 over P. It's just because that's the way we define the value of money. Okay, so as the value of money rises, the price level falls. You see, as price level falls from $4 to $2 per basket, each dollar, it only was able to buy 1/4 of the basket, and now can buy 1/2 of the basket. It's getting more strong, basically. And the dollar is getting stronger as the price level is falling, okay, up until this point. So the money supply looks like this, right? The Fed sets a certain amount of money regardless of the price, but however, the demand curve is downward sloping. In other words, people want more money, right? People want more money as the money gets more worthless. That's another way of saying people want more money as the price level goes up. Okay, so that's kind of what we're looking at. And so basically, supply and demand graph, the equilibrium value of money, and we have an equilibrium price level. Just like always, we set supply and demand equal to each other. All right, now suppose the Fed increases the money supply. Look what happens to the value of money. The value of money falls, which makes the price level fall. The price level increase. So when the Fed increases the money supply, the price level also increases. Another way of saying, when they put in money in the economy, prices go up. All right, so basically, how does this work? Well, at the initial price, an increase in monetary supply causes too much money. People get rid of that extra money by spending it on goods and services. So what does that look like? Well, in the regular supply and demand graph, not the one that we just drew, but the regular one for the market for goods, the demand increases, which makes the price of each good increase. Okay, so since the prices go up, then it happens to all of the prices, and that's what happens in the long run. All the price levels go up. Okay, in the short run, other things happen, but we're going to study that in other chapters. So quick review, real versus nominal variables. Nominal variables are measured in monetary units, nominal GDP, nominal interest rate, nominal wage. It's in dollars, right? Real variables is actually what we actually care about. It's measured in physical units, the amount of things that we can buy, right? Real GDP, real interest rate, real wage. Prices are normally measured in terms of money. So think of a price of a compact disc, price of pepperoni pizza. However, there's this very interesting kind of price. It's the relative price. It's how much something costs in relation to another, right? So price of a CD to the price of a pizza is 1.5 pizzas per CD. Notice that's not measured in dollars anymore. That's measured in products. In other words, that's a real variable, okay? That's a real variable. Another real variable is the real wage. So if W is the number of dollars you get paid, right, $15 per hour, and P is the price level of goods, say $5 per unit, then real wage is how much you can buy, W divided by P, which is equal to 3 units, right? So each hour you work, you buy 3 units. This is ultimately what we actually care about, is the real wage. All right, so this gives rise to this thing called the classical dichotomy, that nominal and real variables are separate. So Hume, the classical economist, suggested that monetary policy, right? So when the Fed pumps money into the economy, it only affects nominal variables, not real variables. So if the central bank doubles the money supply, all nominal variables, including prices and wages, will double, but real variables, including relative prices, will remain unchanged, right? So it's basically, if they put more money in the economy, everything gets more expensive, including my labor, so I get paid more, and I actually can't buy anything else. I can't buy any additional goods. I don't feel any richer. That's called real variables are being unchanged. And the idea here is that money is neutral, right? In the long run, money supply cannot affect real variables, right? So when doubling money causes all nominal prices to double, but what happens to relative prices? Well, let's look at the original example. Let's double those prices, and we realize the relative price is unchanged. And remember, the relative price is a real variable, so no real variables move when the monetary supply increases. The real wage also does not change. So that means that the quantity of labor supplied does not change, the quantity of labor demanded does not change, total employment does not change, and this applies to all inputs. So since employment is staying the same, then we know that total output is also unchanged. So changes in monetary supply cannot help our economy create more goods, which is really ultimately what determines our standard of living. So this is really only true in the long run. In the short run, it has effects. We'll see those later. I want to introduce this idea called the velocity of money, because this is the other way that we're going to see how the prices rise when the Fed prints too much money, right? The first was the supply and demand graph. The second is this equation. So let's call P times Y the nominal GDP, price level times real GDP, right? M is the monetary supply, and B is the velocity, how many times a dollar changes hands. So really all I do is I see how many total dollars that are needed of stuff to buy divided by the total number of dollars, and that gives me the number of times a dollar changes hands, right? So let's imagine with pizza. In 2012, Y was equal to 3,000 pizzas. Price level was $10 per pizza, so that means that the nominal GDP was $30,000. There was only 10,000 $1 bills. Imagine they're in $1 bills, right? So $10,000 bills out there. That means each dollar bill got used 3 times. Okay, basically is what the idea with velocity is. So let's do this real quick. Let's imagine that we have 800 bushels of corn. V is constant. The monetary supply is 2,000, and the price is $5 a bushel. Would you please find nominal GDP and velocity? All right. Take a second, pause this, figure it out, and then come back. All right, so basically nominal GDP is $4,000, just P times Y, and velocity is just P times Y divided by M, which is 2. As you can see from this graph, nominal GDP and M2, that's one of the ways of measuring, remember I taught you this in a previous chapter, it's one of the ways of measuring the money supply. They go up together, and that means that the velocity down here of money stays the same. So velocity is pretty constant. You can see this green line just pretty much stays flat the entire time. All right. In this is going to give us the quantity equation. So we multiply both sides by m, and we have this, and it's called the quantity equation. Now, we know that v is stable from that graph that I just showed you. It doesn't change. So if m goes up, that means, right? So if m goes up, that means the Fed pumps more money into the economy. Something over here has to go up, right? This is the idea. Well, a change in m does not affect y because money is neutral, and y is the actual number of goods. So we know that this thing cannot be changed. What has to be changed is p. So when m increases, p increases, right? And it changes by the same percentage. In other words, growth in the money supply causes inflation. This is kind of the algebraic or equation way to think about what happens when the Fed prints too much money. So use this same formula and the data given here, except for I'm going to go ahead and have the Fed increase the money supply by 5% to $2,100. So I need you to compute the values of nominal GDP and the price. I want you then to suppose that and compute the inflation rate. Then suppose that y increases to 824 and look at the inflation rate there. All right, so let's go ahead and compute the 2009 values. So nominal GDP is we're going to have to get it from m times v. Because we don't actually know p to be able to multiply it times y like we did last exercise. So we're going to get it from m times v. What's m times v? It's 2,100 times 2. It's $4,200. So that means that p has to be equal to 4,200 divided by 800 is $5.25. So the inflation rate, right, new minus old over old is 5%. Same as the money supply, right? This is exactly what we saw earlier. When the money supply goes up by 5%, then the price level goes up by 5%. Now let's say, though, that y increases to 824 this time. So when I do the division this time, the price level is only $5.10. The inflation rate then is only 2%. So here's the summary, right? If real GDP is constant, then inflation rate equals the money growth rate. If real GDP is growing, the inflation rate is less than the money growth rate. The bottom line, right? When I have GDP growth, meaning y increases, that increases the number of transactions, and so the extra transactions need some more money, but if you put in too much money, it causes the prices to go up. We call that inflation. Now, when I have inflation more than 50% per month, it's called hyperinflation, and this is always caused by when the government prints too much money. All right, so here's an example. In the late 2000s in Zimbabwe, the government presses were turned on, and you can see, like, look at, oh my goodness, how the cost of a dollar increased up to 26,421,000,000 something dollars, Zimbabwe dollars, right? That's because they just kept printing money because the Zimbabwe government didn't have any way to finance its funds, so they just printed fake money. It made all of the prices go up. There were even people throwing them in the toilet because they were cheaper than toilet paper. Crazy, huh? All right, let's talk about some of the costs of inflation, or the bad things of inflation. There's something that's kind of hard to think about. It's called the inflation tax, right? So let's say that the government doesn't have enough money to cover its expenditures, so it prints money to pay its bills, right? This is how hyperinflation starts. Well, it's actually like a tax, because everyone who's got money in their pocket, right, the money in their pocket becomes worthless as the government prints more money. The government uses that printed money to pay its bills. So really, it's like as if the government is very sneakily reaching its hand into people's pocket, taking it out, and using that money to pay bills. But it only is charged on people who hold cash. If you put your money in the bank, the inflation tax doesn't apply to you. In the United States, the inflation rate is low. It's like less than 3%. So it accounts for a little bit of revenue that the United States government makes, but not a lot. Let's talk about this thing called the Fisher effect. the nominal interest rate is equal to the inflation rate plus the real interest rate, right? So the real interest rate comes from the market for loanable funds. Remember that supply and demand curve that we drew a couple chapters ago? And then, of course, the inflation rate is determined by money supply growth. So the nominal interest rate is determined by the addition of those two variables. Now, in the long run, money is neutral. So a change in money growth affects the inflation rate, but not the real interest rate. So basically, if you make the inflation rate go up by printing too much money, you're going to make the nominal interest rate go up by exactly the same amount. It's called the Fisher effect. Now, you can see how closely that the nominal interest rate and the inflation rate follow each other. That's the Fisher effect right there. And so, remember, the inflation tax applies to people who hold cash, not if they hold wealth in other forms. And so the idea here is the increase in inflation causes an increase in the nominal interest rate right here, but not the real interest rate, so that if you're earning the real interest rate by perhaps owning property or something like that, you're exempt from the inflation tax. Let's look at some other costs of inflation. But first, let's say what inflation doesn't do. Most people think that inflation takes away your real income, meaning your ability to buy stuff. But it doesn't actually, because yes, prices go up, but your price of your labor also goes up. So real incomes are determined by real variables and not the inflation rate. You see that in this graph, the cost of goods, the CPI, and the nominal wage, what people get paid, are both following up at the same rate. Basically, people are not losing money, losing purchasing power when the prices rise. So here's some costs. Shoe leather costs. I have to run to the bank because I don't want to hold money anymore, because every time I do, I get subjected to the inflation tax. I have to run to the bank a lot. That's called shoe leather costs. Okay. Menu costs. If prices are changing, we have to reprint menus, and that costs some money too. Okay. This one's a little more confusing, but basically people don't understand what's going on. Is the general price level, i.e. inflation, going up, or are more people trying to spend money on my good, right? The firm doesn't know if this is just more people running and spending money on my good, or if it's just everybody has more money because of inflation. So it distorts the allocation of resources. And confusion and inconvenience arise all the time when we're not exactly sure if the money's going up because of inflation or the money's going up because more people want the good. So it really complicates long-range planning. It can messes up tax, right? Inflation makes nominal income grow faster than real income, and taxes are based, unfortunately, on the nominal income. So inflation causes people to pay more taxes even when their real incomes don't increase. Check this out. Let's imagine you deposit $1,000 in the bank and do it in two cases. One with 0% inflation and a 10% nominal interest rate, and the other with inflation and a 20% nominal interest rate. So let's answer the questions. In which case does the real value of your deposit grow the most, when we assume the tax rate is 25%? In which case do you pay the most taxes? And we're going to compute after-tax nominal interest rates, right? And after-tax real interest rates. So go ahead and pause and then come back when you're done. All right, let's examine this here. In both cases, the real interest rate is 10%. So the real value of your deposit is the same. In the most taxes, actually, you pay $25 in case 1, and you pay $50 in case 2, right? Because you make $100 of income, right? 10% times 1,000 is equal to 100 here. 1,000 times 20% is equal to 200 here. And so when you apply the tax rate, you pay much more in case 2. Let's look at the after-tax nominal interest rate. So the nominal interest rate is you make $75 in after-tax income from $1,000. This is when there's no inflation, right? So 7.5%, and the real is also 7.5% because there's no inflation to subtract off. But in the world of inflation, right, you're making $150 after-tax income, so you're making a 15% after-tax income, and the real interest rate is only 5%. So you see the real interest rate actually falls after tax when you have inflation. So basically, it raises nominal interest rates, it increases savers' tax burdens, and it lowers the after-tax real interest rate. Okay, and so here's another cost of unexpected inflation is arbitrary redistributions of wealth. In other words, if you have a loan, right, and you've borrowed money from someone, and inflation makes the price level go up in the future, you get to repay their debt with dollars that aren't worth as much. So that's better for you, right? But then if the inflation is actually is lower than expected, then it's actually worse off for the borrowers and better for the lenders. We call them also creditors. And so when you have high inflation, you might have really variable and less predictable trends. So if you stick with low inflation, then it's easier to guess, and so you don't have these arbitrary redistributions of wealth. All right, really, all these costs are quite high for economies with hyperinflation. In economies with lower inflation, the United States being one of them, these costs are probably much smaller, but we're not exactly sure how big. So basically, the conclusion of this chapter is that prices rise when the government prints too much money. We saw that money is neutral in the long run, meaning it only affects nominal variables, and it does do things in the short run, but we will study those in later chapters.